All right, welcome back. Today, we are diving into a real cosmic detective story. I'm talking about discoveries that could, well, they could completely shatter our basic understanding of the universe. We've found things out there so vast, so strange, they challenge the very rules of how everything is supposed to be put together.
Okay, let's just start with a number. In 2024, astronomers announced they found a structure, way out in the distant universe, that measures 1.3 billion.
That's light years across. Now, to give you a sense of scale, our own Milky Way galaxy, that's only about 100,000 light years wide. So this thing is just wow. Get this. If you could actually see this big ring in the night sky, it would take up the space of 15 full moons side by side. It is just unimaginably huge.
And here is the big mystery, right? According to our best theories of cosmology, a single structure of this size simply shouldn't be possible. It's a cosmic rule breaker. So, what is going on? Let's get into it.
So, clue number one in our investigation is this big ring. It's located a staggering 9.2 billion light-years away from us. And it's not a ring like Saturn's rings, right? It's a gigantic, almost perfectly circular arrangement of whole galaxies and galaxy clusters, just hanging there in the sky.
Now, to really get why the Big Ring is such a bombshell, you need to understand the one fundamental rule it seems to be breaking. This is a core assumption we make about everything.
It's called the Cosmological Principle. And look, this isn't just some casual idea. It's a cornerstone of modern cosmology. It is the fundamental assumption that lets us build our models of how the entire universe has evolved. You know, without it, a whole lot of our math about the cosmos just falls apart.
Think of it like this. On the absolute grandest of scales, we expect the universe to be smooth, no huge lumps or voids. But the Big Ring, well, it's a colossal, completely unexpected lump in that cosmic butter. It's a huge hint that the universe might not be as uniform as we've always believed.
In fact, based on that cosmological principle, scientists have calculated an actual theoretical size limit for any structure in the universe, and that limit is 1.2 billion light-years. Well, the Big Ring clocks in at 1.3 billion light-years. It literally steps right over the line. It breaks the known limit.
Okay, so let's move to our next clue, because this is where the story gets even stranger. See, the Big Ring isn't some isolated freak of nature. It might actually be part of a whole family of impossibly large cosmic structures.
Turns out, the very same PhD student Alexia Lopez who spotted the Big Ring, a few years earlier, she discovered something called the Giant Arc, a mind-bendingly huge crescent of galaxies that is almost 3 times bigger than that theoretical limit.
And here's the real kicker. Finding one giant structure? Okay, maybe it's a fluke, a 1 in a billion chance. But as Alexia Lopez says right here, finding 2 of them, and get this, finding them in the same patch of sky, cosmologically speaking, that really suggests something is going on that our standard model just can't explain.
And the plot thickens. Other teams of scientists have found these vast cosmic filaments where entire galaxies seem to be spinning together in sync, like a cosmic teacup ride. This coordinated rotation across millions and millions of light years, it totally challenges our ideas about how galaxies are supposed to get their spin in the first place. So when you've got not just one, but multiple, independent observations of structures that seem to defy our models, it forces you to ask a really big question. Is our whole understanding of the universe's large-scale structure just wrong? Could these be clues pointing us toward entirely new physics?
And of course, scientists are already on it. They're exploring some truly mind-bending possibilities. I mean, if the old rule book doesn't work, what new one possibly could?
In the explanations they're kicking around, whoa, they are pretty out there, but they're not just random guesses. We're talking about things like cosmic strings, these theoretical glitches left over from the very beginning of time. Or how about conformal cyclic cosmology, that's CCC, a wild theory from Nobel Prize winner Sir Roger Penrose. He suggests these giant rings could be echoes or scars left behind by black holes from a universe that existed before ours. I mean, come on, these are serious concepts from some of the heaviest hitters in physics.
But hold on, here's the classic twist in our detective story. Before we go and rewrite all the physics textbooks, we have to ask a crucial question. You know, the one that's at the heart of all good science.
Exactly. A healthy dose of skepticism is absolutely vital in science, and a lot of cosmologists are rightly urging caution here.
It's one thing to see a pattern in the data, but it's another thing entirely to prove that pattern is a real, physical thing.
For instance, some critics have pointed out that the Big Ring was announced to the media before a full scientific paper was even published for other scientists to pick apart. As this quote notes, that's a pretty unusual way to do things, and it makes it really hard for anyone else to independently verify the claim.
So here's the bottom line. Extraordinary claims require extraordinary evidence, and right now the jury is very much still out. It's entirely possible this is all just a statistical fluke, a kind of optical illusion in the data that our pattern-seeking brains are latching onto. Similar huge claims have been made before, only to be questioned after other scientists got a closer look at the numbers.
And that brings us to the exciting, but yeah, pretty uncertain end of our story. For now. It feels like we're staring at a puzzle where some of the pieces just don't fit, and we don't know if the pieces are wrong or if the picture on the box is wrong. Right now, we are truly on the frontier. This is what science actually looks like in action. It's a debate, a tug-of-war between a potentially revolutionary discovery on one side and the rigorous, painstaking process of verification on the other. It's a clash between seeing something new and proving it's actually there.
And really, that's the big takeaway here. Whether these giant structures turn out to be real or not, the search for the answer is what's important. It's what pushes us to build better tools, to look deeper, and to question everything we thought we knew for sure. It's a perfect reminder that the next massive discovery might be hiding right there in plain sight, just waiting for someone to ask the right kind of crazy question.